Hello and welcome to a video on geometry theorem practice. On the practice, what you'll have to do is you'll have to do all the problems to the left and you'll have to create your own problem to the right. So in this video, what I'm going to do is I'm going to do all the problems that are on the left, and that way you can just focus on creating your own problem. Here in the first problem, we have in the figure above, A equals 100 degrees. What is the value of B minus C? So there's one thing I want to point out first, that on the SAT, what you might see a lot is that they ask for their answers in terms of an expression. So our final answer will be B minus C. Well, in order to find that, we have to use the diagram to figure out what B is and then to figure out what C is. So they give us A in the problem. A is 100 degrees. So if I write 100 degrees in here, I can use a linear pair, right? A linear pair is two angles that form a line, or 180 degrees. A and B are a linear pair. So if I know that A is 100 degrees, B is going to be 80 degrees. And that's great news, because B is one of the things that we need to know to find our problem, to solve our problem. Now, in order to find C, so C is down here, and I know due to vertical angle theorem that C's angle is going to be equal to this angle of a triangle. So this is going to be C. I also know due to vertical angle theorem that this angle of the triangle is going to be 80, because 80 is vertical to that angle. So I have 80 degrees here. I know that that's C degrees, and then I know that this little square right here is going to be 90 degrees. So due to the triangle sum theorem, I know that if I'm missing one angle of a triangle, I can use the other two angles to find the missing angle. So in order to find angle C, so angle C is going to be equal to 180 minus 90 plus 80. Squeeze it in there. So 90 plus 80 is going to be 170. So C is going to be equal to 180 minus 170. C is equal to 10 degrees. Well, that's great news. So I have B. B is 80. C is 10. And my final answer will be 70. Let's take a look at number 2. In number 2, we have line A and B are parallel. What is the value of X? So first things first, let's mark off our two lines that are parallel with our parallel designation. The other thing I know about parallel lines is when they're cut by a transversal, it makes two exact copies, sets of angles. So if I'm looking, they gave me 125 degrees in this larger angle to the right. So if I'm looking at the exact copy here, I know that this angle right here is also going to be 125 degrees. So if I know that whole angle is 125 degrees, and I know that part of it is 52, then, well, we could write the algebra out here. 52 plus x equals 125. In order to solve for x, I would just take 125 and subtract 52, and I would get 73. degrees. The tricky part of this is this ray that breaks up these angles here. That kind of throws everyone off. Don't let that deter you when you're trying to solve these problems. Let's take a look at number 3. In number 3, it says, in the diagram above, what is the sum of A plus B? So once again, SAT is asking for an expression. So I take a look at what I have here. So A is vertical, once again, to an angle in a triangle. B is vertical to angle in a triangle. So I know that this is angle A, this is angle B. And what I have here is I have an external angle or an exterior angle. And the exterior angle theorem states that the sum of the two opposite interior angles, so here's my linear pair, right? But the two internal angles that are not involved in the linear pair add up to 115. So according to the exterior angle theorem, A plus B is equal to 115. And the answer was in the diagram the whole time. Let's look at number 4. In number 4, it asks, what is the value of x? So I find x in my diagram here, and I'm going to evaluate what I have. So I know, according to the vertical angle theorem, that x is going to be equal to the angle that's vertical to it. So x degrees can be put here. Well, these 3 angles form a line. And whenever we have a line, I know that the sum of those angles will be equal to 180 degrees. So now if I set up a little algebra equation here, I have 2x plus x plus 3x is equal to 180 degrees. I'm going to add like terms here. So I have 2x plus 1x plus 3x. That's going to be 6x equals 180 degrees. Divide both sides by 6, and I get x equal to 30. And we've found the solution. Let's look at number 5. I believe these are on the back of the exercise. So here in number 5, it says the figure above shows a parallelogram with one side extended. If z equals 40, what is the value of y? So what we have here is we have this external angle broken up into 3 angles. So z is 40. So I have 40 degrees, 40 degrees, 40 degrees, right? And this whole external angle is 40 times 3, or 120. The other thing I know here is that this external and this exterior angle is a linear pair with the corner angle of the parallelogram. So if I take 180 and I subtract 120, I'm going to get 60 degrees. Now I have to remember a property of parallelograms, right? In a parallelogram, opposite angles are equal. So if opposite angles are equal and y is opposite 60 degrees, I know that y is also 60 degrees. Let's look at number 6. number 6, it says, in the figure above, a line segment BA is congruent to line segment DE. What is the value of X? So first, let's record this part on the diagram. BA is congruent, which means equal to DE. So BA is here, and DE is here. So what we have here is we have overlapping triangles, and this can be confusing. So let's do this. I have one triangle that looks like this, and it's got a right angle here, and that's it for that one. That's all we know about that one. And then I have another triangle here that is also a right triangle, and it's got 55 degrees up here. Well, on this triangle, see, I'm lucky to know that it's a right triangle because that is going to be 90 degrees here. And because I have the 90 degrees and the 55, I know that if I add them up and subtract from 180, I'll get that third angle. So 9 plus 5 is 14. That's going to be 145. And then if I subtract 180 minus 145, I'm going to get 35 degrees. Well, this is great news because on my diagram, it also says that these two sides are equal. And what this tells me is that I can use the angle-side relationship theorem, right? The angle-side relationship theorem states that the smallest side is opposite the smallest angle, and the largest side is opposite the largest angle. And then subsequently, the equal angles are opposite equal sides, etc. So because these are equal sides, I know that this also has to be 35 degrees. So what I have here is I have 35 degrees here, 35 degrees here, and then once again, I have the triangle sum theorem, right? And I can find X. So a 35 and 35 is going to be 70 degrees. And then if I subtract 180 minus 70 degrees, I get 110 for X. Let's try number 7. So in number 7, it says here, in the figure above, triangle ABC is isosceles. Line segment AC is equal to line segment CE. What is the value of X? So what I have here is I have two overlapping triangles. I have, again, and I will be the first to admit that overlapping triangles does confuse a lot of students. So sometimes it's nice to be able to highlight what you're working with here. So we have one triangle here, and I'll change colors. And we have another triangle here. So that even though it looks like a star, we actually are just dealing with a couple of triangles. Let's now identify what this says here. So it says here we have an isosceles triangle, and AC is equal to CE. So AC is here, so we'll mark that off. And CE is here, right? So a couple tick marks on each of those. And again, going back to our last problem, right? We have the angle-side relationship theorem, right? where the largest side is opposite the largest angle, the smallest side is opposite the smallest angle, and equal angles are opposite equal sides. So if I have a set of equal sides here, I know that angle A is going to be equal to angle E. Congruent. And from here, I know that I have one angle plus that same angle plus 110 is going to be equal to 180. And I know this because of the triangle sum theorem once again. So again, I have 2x plus 110 equals 180. Here I have 180 minus 110. Well, 180 minus 100 is 80, minus 10 is 70. So 2x equals 70. And then if I divide by 2, I get 35. So I have 35 degrees, and that is going to be angle A and angle E. Well, that's great news, because now I'm dealing with this relationship right here where I have 50 right here, I have 35, and then I have the angle that's vertical to angle X. So this looks like it's going to work out great. So I can use the triangle sum theorem to find this missing angle right here. And then I can use the vertical angle theorem to find the measure of angle X. So let's do that. So I know that 180 minus 50 plus 35 is going to give me the missing angle. So 50 plus 35 is going to be 85. And then 180 minus 85 is going to be 95. So I know that this angle right here is 95. And then I know that that angle is vertical to X. So I know that X is also 95 degrees. All right, there's one more problem on the make your own test question sheet. Let's take a look. So it says here, in the figure above, the figure above is a regular pentagon that has been divided up into 5 congruent isosceles triangles. What is the value of X? So there's a couple things that we need to know about this situation. So a regular pentagon means that all the sides and all the angles are equal in a regular pentagon. And specifically, I'm looking at this situation here, right? We have these inside angles, right? So if I know that they're all equal, I can figure out what one of them measures, right? So if I'm dealing with, if I'm dealing with a line, right? Now we've clearly said that a line is 180 degrees. We've said that over and over again in the class. However, this is not only a line, but comes back around. So essentially what it did is it formed a circle. And so what it did is it did another 180 degrees. So I have 360 degrees. And I have 1, 2, 3, 4, 5 of them. And they're all equal. So what I can do is I can take 360 and divide by 5 to get the measure of one of the angles. So the measure of one is going to be 72 degrees. Well, great. So how does this help me? Well, if I look down at my problem here, is we have an isosceles triangle. So in other words, all of these sides are also equal. And again, we are dealing with that angle side relationship theorem. So I know that this is also going to be x. So I have, using the triangle sum theorem, x plus 72 equal to 180. I have 2x plus 72 equal to 180. I'm going to subtract 72 from 180. Well, 180 minus 70 is going to be 110. 110 minus 2 is 108. So I get 2x equals 108. Dividing both sides by 2, I'm going to do 108 divided by 2, and I get 54. And that is going to be the measure of x. So those are all the practice questions on the make your own test questions. If you have any lingering questions or you're not sure as to how to create your own question, send me an email or ask a question in class. Thanks.